This is 2.3, day 1, polynomials with long division, introduction to synthetic division. This first example I don't want you to write down, just reviewing how you did long division in elementary school. 5,643 goes underneath that division symbol, and the 12 goes out in front. Then we look and see if 12 goes into 5. It doesn't. 12 goes into 56 4 times. So you put the 4 above the 6. And now we multiply. 4 times 2 is 8. 4 times 1 is 4. Put the line underneath it, and then you always subtract. So 6 minus 8 doesn't work, so we're going to take the 5 and reduce it down to a 4. And now we have 16 minus 8 is 8. Then we're going to bring down that 4, because 12 cannot go into 8. But now 12 can go into 84. How many times?
7.
7? Okay, so 7's going to go right there. So now we say 7 times 2 is 14. 7 times 1, so you're carrying it. And subtract. 0. Bring down the 3. Can 12 go into 3? No, so this is what we call our remainder. All right, next example. Highly recommend you write it down. Use long division to factor this. So we're going to factor out the x minus 2 from this cubic polynomial. So the x minus 2 is going to go in front, and then the cubic function is going to go underneath the division symbol. Now we're going to look at the first term, and we're going to see if it can divide into the first term. So I'm looking at this x and that 6x cubed, and just off to the side, I'm going to divide them. So I'm going to say 6x cubed. If I divide that by x, what am I left with? 6x squared. So now what's going to happen is that is going to be my first part of my answer, 6x squared. Now we're going to go ahead and multiply. We're going to multiply the 6x squared times both parts in front to the negative 2 and the positive x. So we say 6x squared times negative 2 is negative 12x squared. Then 6x squared times x is 6x cubed. Now what you have to do every single time is subtract the terms. So I subtract here, but I also have to subtract the second term. So what it's doing is it's changing the terms. So subtract, now change that negative to a positive. Now what do we do with those columns is we look at them. 6x cubed minus 6x cubed is 0x cubed. And then negative 19x squared plus 12x squared is negative 7x squared. Now I have two terms out in the front in the blue, so I have to bring down that plus 16x. All right, now I have to figure out how many times I can divide x into negative 7x squared. So just off to the side, negative 7x squared. I'm dividing it by that x minus 2. So I'm just going to work on the first two terms. Where I found that is the negative 7x squared and that x. And what am I left with? Negative 7x squared divided by x. Negative 7x. So that's going to go right above the 16x term. Oops. Now I'm going to take that negative 7x and multiply it to the two blue terms. So negative 7x times negative 2 is positive 14x. And then negative 7x times x is negative 7x squared. What do I do with those two terms? Subtract them. We'll always change the signs. So now this becomes a plus, and that becomes a minus. So now negative 7x squared plus 7x squared becomes 0. 16x minus 14x is 2x. I can't divide those, so I'm going to bring down the minus 4. Now off to the side, 2x divided by x is 2. So that's what's going to go above right there. And now what do I do with that green 2? The pot plus 2. Multiplied by the 2 in the front again. So negative 7x. Uh-oh, I think my smartboard needs to be calibrated. Okay, so now we multiply. So 2 times negative 2 is negative 4. And then 2 times x is 2x. Now what do? Subtract them again. Change those signs. Where students make mistakes is they forget to change maybe the second term. So now minus and plus. So now 2x minus 2x is 0. Negative 4 plus 4 is 0. I did not get a remainder. So what this tells me is that this polynomial is factorable by x minus 2. So now my answer in factored form, I took out the x minus 2, and I'm left with 6x squared minus 7x plus 2. 6x squared minus 7x plus 2. If I got a remainder, like let's say 3, then it's not factorable by that expression x minus 2. I'm going to stop the recording there. We have more problems and examples to do.